let's do this. I'm gonna get my notebook. Okay.
What's your day as a person? So what's going to go down on the freshman level today? One day?
It's one day.
Is it during school or?
After school. Oh, shoot.
You by yourself?
Well, it'll be good. It'll be fine. My stress level is a little crazy. Let's be quiet. Vacuum. I can't bite it. Ready? Segments of the chord. Going to define what it means to be a segment of the chord. It is the two segments that are created when two chords intersect in the interior of the circle. segments of chords there. It says if two chords intersect in the interior of a circle, then the product of the lengths of the segments of the chords is equal to the product of the lengths of the segments of the other chord. So if two chords intersect in the interior of a circle, then the product of the lengths of the segment of the chords is equal to the product of the lengths of the segment of the other chord. Make sense? Draw a circle. Okay, segments of the chord up at the top. It said that it has two segments are created when two chords intersect in the interior of the circle. So here are two chords intersecting, correct? So now you have segments. Make sense? Okay, so it says right here, when you have two segments, two chords intersecting, it's the product of the lengths of the segments. So the product of the length of a segment, so since this is breaking up into two pieces now, it's AE and EB, correct? So I can say that EA times EB equals the other two segments of the other chord, which is EC times ED. Make sense? I'm going to define a couple words and then we're going to do another theorem similar to what I just did. Like define a word and then do the theorem that has the word. Secant segment. What does it mean to be a secant?
A line that intersects the circle at 2 points.
Good. Intersecting 2 points. Segment just means it's not going to be a line though, it's going to be a A segment. Now the secant segment is a segment that contains a chord of a circle and has exactly one endpoint outside the circle. Which means the other endpoint is located where? Or on the circle, right? External segment. What does external mean? Outside. What are we going to be outside? Outside of what? Outside of the circle. It is the part of the secant segment that is outside the circle. Alright, let's draw a secant segment. Let's draw this segment. Alright, secant segment. What is the external segment going to be? Outside the circle. Remember, it's part of the secant segment, so here's your external segment. I'm going to highlight it pink so you can see it. Excuse me.
Is the whole line, like both the lines, triangle,
No,
or is it just the top?
just the top piece. Because I'm going to label the bottom something else. What do you think the bottom's going to be? What? It's not internal. Secant touches twice. What's this one? Tangent segment. Why is it tangent? It only touches once. Emily.
Oh, I was looking for the blue one.
Oh, wait a minute.
Thanks, babe.
Good? Makes sense? Question? I'm going to turn the page. She's like a bullying me.
What?
What's wrong?
It's a lot more circle. You know what?
Are we good? So I can turn the page.
Yes.
All right. Segments of secants theorem. Draw a circle. I am not going to write words. I have two, what here? What are they? Two secants. Draw that, and I'm going to give you a second, and I want you to watch the next piece. Ready? Yeah, it's in my teeth. Pretty much everywhere. Okay. Here we go. Watch. Don't write.
Okay.
Listen to what I say. Ready? The piece times the whole thing equals the piece times the whole thing. The piece on the outside, so the external segment, right, times the whole secant segment equals the external segment times the whole secant segment. Make sense? Okay, write it down. Ready? Because we're going to do another one. This one's going to be labeled segments of secants and tangents.
What?
Yes. There. Segments of secants and tangents theorem. Ready? Draw a circle. Draw a tangent. Draw a secant. And then put your pencil down. Ready? Okay. This one says the same idea. Now watch. Remember on the other one, it was the piece times the whole thing, right? So that still is true for one half of it. The other side, remember the piece is located where? Outside. So if I look at the tangent segment, this is still technically where? Outside. So it's still the piece, but it's also considered the whole thing. Piece times the whole thing, or whole times whole equals piece times whole thing. However you want to remember that, you can. Or you can write it EA squared equals EC times ED. Yeah, but however you need to remember it, you remember it. Okay? Example time. I'm going to turn the page for my example only because this one's a little long. Okay, there's your picture, there's your problem. What I want you to do is I want you to talk with someone next to you, especially if you're writing in pen. I'd be very careful at this point. Yeah. Did you say no? I'm kidding.
Oh, wait.
Ready?
Yeah. I know what you get.
Okay, let's see if you're right. Let's start with the letters. What letters are we multiplying? RV times VT equals SV times VU. Good. All right, let's plug into what we know. What is RV? X plus 1 times 3x equals,
4x.
Wait, what?
well, I have x times 4x.
Percentage?
What?
11 is if we switch the letters.
It's fine.
Okay.
As long as you multiply correctly. Let's see if you multiply correctly.
Dios.
What do we get on the left?
3x squared
3x
plus 3x.
squared plus 4.
Oh, yeah.
Okay, that's what I meant.
Yeah.
Oh.
You know what? I'm not right.
Equals what?
4x
I
squared.
didn't do it.
How many of you had that right?
I had the 4x squared and the 3x squared, but I didn't have plus 3x. Oh.
Yeah, that person.
I thought I was doing so good, man. I was like, yeah, I got this. No.
How was it? How is it? 3x squared. I mean, just 3x, I mean, not just 3x. It's on there. 3x right there.
Explain how you got 3x.
Oh, x squared.
What?
Stop talking.
Oh, sorry.
X times x equals x squared.
And then how'd you get 3x, the regular 3x?
All 3x times 1.
You're distributing.
Oh.
You're multiplying 3x times x and 3x times 1, so it's 3x squared and 3x.
So there's an imaginary one.
No, there's a 1 right there.
Oh. Never mind. I'm gonna just stop.
It's
I'm
okay,
gonna
I'm proud of
listen.
you.
I'm gonna listen.
Don't stop it.
Okay. What do we do now?
Solve.
Why don't you say what we gotta do, sir?
I know, Sam. I thought I was like, I
Question.
thought I got it right.
No. Question.
God, right?
What do we do?
That's what I used. Did you get it wrong?
Subtract the 3x.
Yeah, subtract 3x squared. So I get minus 3x squared minus 3x squared. So I get 3x equals x squared. Now what?
Divide by x.
No. You can't square it because you have a 3x. No.
We subtract
Subtract what?
x, 3.
Yeah, subtract x on both sides.
How about 3x from both sides?
Okay.
So it equals 0.
So it equals 0. Equals.
I don't say anything anymore.
Put the 1
Square minus.
x squared minus 3x. It needs to be in standard order. Then what do I do?
Oh, it was square. Never mind, just kidding. Never mind. Never mind. Just had a crazy like.
Starts with an F. Factor. First question you ask yourself, what do they have in common? They have an x in common. What's left when I factor out the x?
X minus 3.
X minus 3 is correct. How many equations do you need? 2, whatever.
X minus 3, x plus 3.
No.
Okay, never mind. I deal million.
I'll give you x minus 3. I don't know where you got a plus 3. Do you see a plus 3?
No, but like.
No, then no. Mm-mm. This is the one you guys never get.
X equals 0.
X equals 0. How do you solve this one?
Fabulous.
Add 3.
So x equals what?
3.
So you have two answers, 0 and 3, correct?
Yeah.
Now let's think about this. I need to find the length of my segments, yes? So, yeah. 0 can't work, why?
Because you can't plug it in late.
If you plug in 0 here, it would work here, because 0 plus 1 is 1.
Yeah.
But it won't work here, because then you get 0, and it won't work here, because you get,
0.
and that's, and this multiplied is 0, and then you wouldn't have a circle, right?
Yeah.
0 doesn't work. So x is my answer, but that's not what the answer question asks. It asks for the length of what?
So you're gonna go RT.
Yeah, I'm gonna go plug it in. Now let's talk about RT. Tell me what is RT without using 3. What is RT? X plus 1
Times 3x.
plus 3x. Because you're adding. So then you plug in your 3, because that's how you find the segment length.
Okay.
So I get 3 plus 1 plus 3 times 3.
Okay, never mind. I'm right. Yeah.
So what do I get?
It's like 4 plus 9.
4 plus 9,
13.
which is 13.
Okay, wait. You plug in the 3 with the x.
Yeah?
Wait, what'd you say? What? You plug in 3 for x.
Yeah.
What? What do you mean, what? It's so easy. You got this. Come on. You're stressing yourself out. Look at me.
You plug in 3 for x.
Okay, your equation is on the. You see how it's just x plus 1. Because you're doing RT.
Go do SU.
That's just
Plus 3 because it's
so much work.
You see the 3x is part of RT. The whole line right there. So you have to add it in because you're not multiplying, you're adding it. And you plug in 3. And so it's 3 plus 1 plus 3 times 3, which is 9. Oh, okay, got it. I just needed to.
Oh, what? I thought you had to do like that one.
Alright, so we get SU, which is x plus 4x, which is 3 plus,
4 times 3.
which
3
is
plus 12.
3 plus 12, which is
13.
good. Got it?
I can get my diploma now.
Okay, example B, draw a circle. I
Still
took,
have another one.
yeah. There's your slide, find x.
Oh, damn, we have some letters in the word.
If you want, yeah. You can put letters. A, B, C, D.
Got it. I think I got it. I think. I'm not sure.
What'd you get? No.
No? No. I was on.
What'd you get? What'd you get? That's wrong.
I got a fraction.
I got a fraction too.
Fraction's wrong.
Oh yeah. Oh my god, I'm an idiot.
But I feel like it's gonna be a decimal.
It's a fraction.
It is not a fraction.
Is it a
What'd
decimal?
you get?
Is it a fraction? No.
It's a decimal? It's a decimal, right?
So that's, decimal and fractions are the same thing.
I'm done. Never mind. Take back my diploma. I don't care.
Jenny, don't laugh. Hold on, guys. They're the same thing.
One's divided and one is not. Who has an answer? Who has an answer that's not a fraction?
I got x equals 8. That's what I'm
What do you have?
on a 4, so.
You are correct.
How? What? What do you mean?
What'd you get?
Here, we're gonna do it right now. Hey, give me back. Get Emily. seems to be the only one. Here we go. It is the piece times the whole thing.
Yeah, I got that.
What's the whole thing? 3x is incorrect. That's the same thing as 3x.
3 plus X?
That is 3 plus x.
Wow.
The piece, which is what? 4 times the whole thing, which is 4 plus 2.
Wow.
That's 6 over there times 4 equals 3 times 3 plus x. Let's distribute. What do we get? 9 plus 3x equals 24. Do that to both sides. Subtract 9 and you get 3x equals 15 and x equals 5, and Jasmine's correct.
I thought I was doing so good, man.
Once Antonio said you got a fracture, and you said it was wrong, I was like,
I know, I was like, dang, I'm so close to
Wow, I really need to like.
Those of you that wrote 3x, you need to put yourselves a note. When you are adding pieces together, that doesn't mean you put them together. It means you literally put a plus sign in between. When you are adding, you do not just get to say 3 and x becomes 3x. No, it is 3 plus x. Leave the plus sign between, because that's where you mess up. Are there questions? Here's your home.
Wow, wow, wow. What a day, guys. What a day. Honestly, that was so good. Like, I was like, I got this, you know?
circles are going to be the reason why I don't have an A in this class.
Says
the one who passed the test.
Huh?
Says the one who passed the quiz. I know. Do you know how hard I worked? I had to cry and then like get my life together all within like 15 minutes. Hard.
I do that every day.
Just
All right, get to work. Let's go. Let's get work done.
The green book.
The geometry
No,
book.
I made the same mistake. It's okay.
Same thing, G, B, G.
If you grab the green book, you're the wrong book.
Really? Isn't it green? I'm pretty sure.
It's pretty sure it's purple.
Well, yikes. The PB, guys. The PB.
Anything past me, love?
Yenny. You're Yenny.
Oh, so large fits